Hi, right, we're back for part 2 of OPizza. So we got the single individual answer last time. We got the values of x, y, and z, wherever it was. And we've got a unique solution there. The second part is this. A year later, the boys are getting together and they eat beef and onion pizza, chicken and mushroom pizza, and margarita pizzas. So I'm going to start off, I'm going to say let x, y, and z equal the number of calories on a slice of beef and onion, chicken and mushroom, and margarita pizza, respectively. Okay, so we use this word respectively to say x is the beef and onion, y is the chicken and mushroom, and z is the margarita. And so our three equations look like this. Zuma has got the set of equations 7x plus 4y plus 10z equals 1130. River has got the equations 2x plus 9y plus 2z equals 433, and Bradley has got the equations 4x plus 18y, my goodness, plus 4z equals 866. So here we have equations A, B, and C, and we want to try and work this out. Now, if we go to our graphics calculator and we go and enter these values in, so go to menu, go to equations, we're looking at simultaneous equations, so it's F1 with 3 unknowns. We put our values in 7, 4, and 10, 1130, 2x, 9x, 2z, making 433, and finally 4x, 18y, and 4z equaling 866. And we've got all our things entered in there. Now I press F1 to solve it, and we come up with a math error. So from that, we know that the equations are either going to be consistent or inconsistent. So we can say here the graphical calculator has a math error meaning there is no one solution. The equations could be consistent or inconsistent. So that's the next experiment or thing that we're going to have to look at. Now, if we look at these two equations, or three equations, hopefully you can see something happening over here with these two. 866 is double 433. 2z doubled gives you 4z. 9y doubled gives you 18y. 2x doubled gives you 4x. And so we can see that equation C equals 2 lots of equation B. Now, what does that mean? Well, if we think back to the work that we did on planes, both equation B and equation C represent planes. And those planes are basically parallel. Because equation B is a multiple of equation C, it means that plane B is parallel to plane C. And I need to get a bit more space here. This means that there is no solution to these 3 sets of equations. And that's where we'd finish that part. So there is no solution to this. These equations are inconsistent, and we can't find values that would satisfy all of them. So that's the second part. We move on to the third part. We can take a look at that. Right, so once again, I'm going to define my variables. So there I've just gone and speeded up that process. We can see we've got our 3 equations for our 3 variables. And once again, you need to go and enter this into your calculator, which we'll do right now. So there they are entered, and if I go and press F1 now to solve it, once again I come up with math error. So that means the equations are either inconsistent or consistent. So as the graphical calculator has a math error, the equations are either consistent or inconsistent. So we need to see whether we can find any relationship between these 3 equations, A, B, and C. Now, if I look at A and B, if I join those 2 together, that's going to give me 6, that's going to give me 18, and that's going to give me 8. And it just catches my eye that 6 is double 3, 18 is double 9, and 8 is double 4. So it looks as though we've got a situation of A and B added together giving us equation C. If I go and double 659, that actually comes up as being 1318, and that is the sum of A and B. So we can see that since A plus B equals 2C, the equations must be consistent. This means that the planes meet along a single line of intersection, and there are many solutions. So that should be enough to get you through to merit if you get to that stage. If we want to try and find the general solution, then we're going to have to be a little bit more, we've got a bit more calculating to do. So let's try and get the general solution. I'm going to rewrite those equations because I need to work with them in a bit more detail. So to find the general equation, I'm going to need to reduce down my number of variables. So I'm going to try and eliminate one of the variables. And I think the variable that's most obvious to eliminate will be the y's. So let's go and take equation B and from it subtract equation C. So I'm just going to work with these last two equations over here. If I take the one away from the other, what am I left with? I'm left with 2x minus 3z equals, what have we got? That's going to be 41, I think it is, 43. Okay, so I've got an equation now that's just in terms of x and z. What I'll do next is I'm going to say let z equal a. That means that this equation is going to read 2x minus 3a equals 43. So 2x is going to be 43 plus 3a. And so x is going to be a half of 43 plus 3a. So I've now got z in terms of a, and I've now got x in terms of a. All I need to do now is work out y in terms of a. And so I need to decide which is going to be the easiest equation to put this in. I'm going to sub those two values into equation A. So sub into equation A, and equation A is going to look like this. A half of 43 plus 3a plus 9y plus 7a is equal to 616. Keep on needing more space. All right, so now I need to get y by itself. So I'm going to have 9y is going to be 616 minus 7a minus a half of 43 plus 3a. And that's going to be 616 minus 43 over 2 minus 7a minus 3 over 2a, 3a over 2. And this comes to, get the calculator out, 616 minus 43 divided by 2 gives me 1189 over 2, and 7 minus 1.5 is going to give me 8.5, and 8.5 is the same as 17 over 2a. So that's what 9y is. So y by itself is simply going to be 1/9 of 1189 over 2 minus 17a over 2. And just to make that look a little bit easier, 1189 over 18 minus 17a over 18. And so our general solution looks like this. We're going to have a point that's going to be, we'll have the coordinates of 43 over 2 plus 3a over 2. That's the x value. The y value is going to be 1189 minus 17a. all over 18. And the z value is going to be just a. I think it'll be easier if I go and make this part over here 43 plus 3a all over 2. So there's my general solution. And in order to get the full excellence, you then just need to go and find 2 points that lie on the line. And so you need to pick 2 easy points to substitute in. The first of the easy points is to go and make a equals 0, in which case we're going to have the point, let's call it a, and that point is simply going to be, when a is 0, this is going to be 43 over 2. This is going to be 189 over 18, and that's going to be the point 0. There's one point of intersection. Or I could go and say let a equal 1, in which case the point b, if I go and put 1 into here, I'm going to get 43 plus 3, that's 46. 46 over 2 is 23. What am I going to have here? I'm going to have 1189 minus 17. Let's just get that. 1189 minus 17 is 1172 over 18, and the z value is going to be 1. And there I've got my 2 points. So we've said before that there are many solutions. We've now found the 2 solutions that might exist, and so hopefully this means you've got yourself up to an excellence. So what you need to do now is to go and practice. Hope this makes sense to you. Any questions, get hold of me. Goodbye.